Welcome to network analysis. All the study materials can be downloaded from this website and QR code. In this session, we discuss Module 5 topics. The first topic is two-port network parameters. Here we study Z, Y, H and T parameter modeling and some problems on these modeling. A two-port network consists of two inputs. Here we are able to see the input port and output port. Example for two-port networks are transformers, transmission lines. So with this two-port network, we are now going to analyze Z parameter, Y parameter, ABCD or transmission parameter and hybrid parameters. So here we are going to consider the following important point while understanding Z parameter, Y parameter, ABCD parameter and hybrid parameter. The equations for Z parameter is represented by V is equal to IZ, where Z represent impedance, I represent current, whereas Y parameter is represented by I is equal to Vy, where Y is the admittance. In T or ABCD parameters, we are going to map V1 I1 input parameter with respect to V2 I2. In terms of hybrid parameter, we are going to map V1 I2 with respect to I1 V2. We are now going to study open circuit impedance parameter or Z parameter. The equation that we are going to write in Z parameter are as follows, that is the voltage V1 V2 is written in terms of I1 I2. V1 is equal to Z11 I1 plus Z12 I2 and V2 is equal to Z21 I1 plus Z22 I2. Just by putting I1 is equal to 0 or I2 is equal to 0, we get the expression for the various open circuit impedance parameter like Z11, Z12, Z21 and Z22. The model for Z parameter is as shown. Here Z11 represent input impedance and Z22 represent output impedance. Let us solve some simple problems on Z parameters. Find Z parameter for the network shown. Here is the network shown with 2 ohm, 4 ohm and 5 ohm along with the voltage source V1 and V2. Here we have to assume the direction of current flow in this network. For this Z parameter, we are going to apply Kirchhoff voltage law. So, since I have here voltage source, I am applying the current I1 as shown in this direction. Here we have voltage source V2, therefore we are assuming the anti-clockwise direction of current here. So from the definition, we are going to express V1 and V2, that is input voltage and this voltage, output voltage, in terms of the current I1 and I2 as follows. So apply KVL to mesh 1. We can write the expression V1 is equal to 2I1 plus 5 into two currents are flowing in the same direction. Therefore, we are going to write 5 into I1 plus I2. Simplify to get the standard expression V1 is equal to 7I1 plus 5I2. What this 7 represent? It represent Z11. What this 5 represent? Z12. So compare this equation 2 with equation 1 here. So we can map Z11 and Z12 here. Similarly, apply KVL for mesh 2. Therefore, I am moving from negative to positive. Therefore, it is V2 positive. V2 is equal to 4I2 plus here 5. We are having through this resistor two currents are in same direction, 5 into I1 plus I2. Therefore, on simplifying we'll get V2 is equal to 5I1 plus 9I2. So let us call this equation as 3. Compare 3 with equation 1 part 2, that is V2 is equal to Z21I1 plus Z22I2. So map Z21 and Z22. Therefore, on comparing equation 2, 3 with the standard equation, we can write the matrix form of impedance Z 7, 5 and 5, 9. Similarly, let us try to find the Z parameter for the network as shown. We have the network 1 ohm, 1 ohm, here 2 and 2 ohms, and voltage sources. So let us assume the mesh 1, mesh 2 and mesh 3 with current I1, I2 and I3. So let us write the fundamental equation expressing voltage in terms of current I1 and I2. Now let us write the expression for KVL to mesh 1. So V1 is equal to I1 plus 2 into I1 and I3 are opposite in direction, therefore I1 minus I3. Simplify. V1 is equal to 3I1 minus 2I3. So call this equation 1. What we are expecting here is V1 expressed in terms of I1 and I2, but I have I3 here, therefore I had to express I3 in terms of I2 and I1. So we will wait till that expression we obtain. So now let us write expression for mesh 2. KVL equation is written like this: V2 is equal to 2 currents are in the same direction, that is I2 plus I3. Therefore, we can write 2I2 plus I3. Again, compare this equation 2 with the standard equation shown here. Here we have I3 which is to be expressed in terms of I1 and I2. Therefore, apply KVL to mesh 3 by considering I3. Therefore, we can write I3 plus 2I3 plus I2, because I3 and I2 are in same direction, plus 2 into I3 and I1 are in opposite direction. Simplify and get the expression for I3 here. Once I3 expression is available, substitute that in V1 and V2. Now we can express V1 and V2 in terms of I1 and I2. So now compare equation 5 and 6 with the equation 1, that is standard equation. So we can obtain the Z parameter for this network as shown. So let us try to solve this problem. We need to find Z parameter for this network. It is T network. So let us find the parameters here. Write and analyze the mesh I1, I2 and I3. Now we have to express V1 and V2 in terms of current I1 and I2. So for mesh 1, 2 and 3, write Kirchhoff voltage law. So for mesh 1, it is V1 is equal to I1 and I3 are in opposite. Therefore, 1 into I1 minus I3 plus 2 into I1 and I2 are in the same direction. So they are going to sum up here. Now V1 is equal to 3I1 plus 2I2 minus I3. So according to the standard equation, V1 and V2 can be expressed in terms of I1 and I2, not I3. Therefore, we will wait till we'll get equivalent expression for I3 here. Now let us write expression for mesh 2 using KVL. So V2 is equal to 3, I2 and I3 are in same direction, just add, plus 2 into, again I1, I2 are in same direction. Simplify, again we'll get I3, which we have to wait to express in terms of I1 and I2. Now let us write expression for mesh 3. Before that, we have to now replace I3 in terms of I1 and I2. So write mesh 3 equation, 4I3 plus 3 into I3 and I2 are in same direction, plus again here 1 into I3 and I1 are in opposite direction. So I3 minus I1 is equal to 0. Simplify and obtain the expression for I3 here, which can be given by 1 by 8 I1 minus 3 by 8 I2. Now substitute this equation in second and third to get V1 and V2, so that you can express V1 and V2 in terms of only I1 and I2. So on substituting I3 here and simplifying, we are going to get V1 and V2 in terms of I1, I2 only. So now write the Z parameter as shown. So this is the solution for the next problem, which consists of dependent current and voltage source here. We are going to analyze this network. As this network has independent and dependent source, so on observation here, there are three mesh, I1, I2 and I3 currents are marked. Here we are going to see the current, that is 2V3 is equal to I3. That is the first equation we can write, because in mesh 3 current I3 is given by 2V3. At the same time, we are going to see the voltage across resistor 2 ohm is V3. But what is V3? V3 is given by the product of current flowing and the resistance. That is, resistance is 2 ohm and two currents are in same direction. Therefore, I1 plus I2. So now get the expression for I3. I3 is equal to 2V3. Substitute V3 here. So we are going to get expression for I3 is 4 into I1 plus I2. Now apply KVL to mesh 1. Write the equation V1 is equal to I1 plus 3I2 plus 2 into I1 and I2 are in the same direction, therefore you have to add here. Simplify. Now the standard equation of voltage is consists of only I1 and I2 terms. Similarly, now let us write the KVL for second mesh. So here two currents are flowing in opposite direction, 2 into I2 minus I3, and here the currents are flowing in the same direction, so 2 into I2 plus I1. Simplify. Here I3 you will get Substitute I3 is equal to 4 into I1 plus I2 and simplify. We'll get expression for voltage V2 in terms of currents I1 and I2. Now compare equation 4 and 5 with the standard equation. Therefore, we can write the Z parameter for this network is as shown. This is about Z parameter. Thank you. Keep learning. Happy learning.